Good afternoon, class. Here's chapter 3 derivatives, section 3.8, differentials and linear approximation, part 2. So delta y represents rise along the curve, which is f of x plus delta x minus f of x. Moving things around, f of x plus delta x is f of x plus delta. F prime of x is dy dx, and therefore dy is f prime of x dx. And this equation, if we replace the delta y with dy, becomes an approximation. So, for example, the radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters. Use differentials to find the approximate change in the area of a cross section of the vessel. So, what's going on? Cross section is in a circular shape with the area being pi r squared. It has some radius to begin with r, which we know it to be 1.4 to begin with. A drug causes it to go down to 1.3. So the radius goes down to a new radius, creating a difference between the two, which is dr over delta. So we're going to write r is 1.4. dr or delta r is 1.3 minus 1.4, the difference between the two, which is negative 0.1 millimeters. And we want to approximate the change in the area. We want dA, knowing that the area is pi r squared. In other words, you want the shaded region, but you want to approximate it. So this is the translation of the question into mathematical symbols. So as f prime of x is dy dx, and therefore dy is f prime of x dx, then a prime of r is dA dr, and therefore dA is the product of a prime of r and dr. That's what we are looking for. So we start with a equals pi r squared, and we want to find dA dr, and pi is just a coefficient, and it's going to remain times. Now we're going to differentiate r squared with respect to r, and we get 2r, simply 2 pi r. So that's a prime of r, or dA dr. What is dA? The product of the two, 2 pi r dr, which means now we can evaluate this by replacing r with 1.4 and dr with negative 0.1. So 2 pi times 1.4 times negative 0.1 results in negative 0.28 pi units of the area millimeters squared. Approximation, you can put it into a calculator with so many decimals, becomes negative 0.8796 millimeters squared. Always draw the setting, show your variables, come up with the exact answer, and the approximation if they ask you. What does it mean? The area of the cross section of the vessel is decreasing. Why is it decreasing? Because this is negative. By this much, 0.28 millimeters squared. Again, when we mention decreasing, we just don't write the sign. Increasing means positive, decreasing means negative. So that's an approximation. The exact amount is delta A, which means you can evaluate the area for the smaller one, pi r squared, put 1.3. And for the bigger one, pi r squared, r is 1.4. The difference is what we want. And I've factored out the pi times 1.3 squared minus 1.4 squared, and you get negative 0.27 pi millimeters squared. Notice how close they are. Again, We can calculate the exact, and we don't need a calculus, okay? Just algebra, geometry unit. A bacterial colony has a population of P of t equals 20 t over 10 plus t squared in millions. T hours after a nutrient is introduced. Use differentials to approximate the change from t equals 2 to t equals 2.4. So what is given? T equals 2, and their difference is dt or delta t. In other words, 2.4 minus 2, or 0.4. And since they want an approximation, that means we want dp. That's the meaning of it. Well, here's P of t. If we find P prime or dp dt, then dp would be what we get times dt according to this. So we are going to say P of t is this, P prime is dp dt, and we want dp, which is the product of these two. So first, we are going to find P prime of t. We notice it's f over g, and we use the quotient rule, f prime g minus g prime f over g squared. So P prime or dp dt is, f prime is 20 times g, 10 plus t squared, minus g prime, the derivative of the bottom is just 2t minus 2t, times f, the top is 20t. And then put the bottom and square it. That's g squared. So 10 plus t squared, quantity squared. Let's distribute and combine terms. (200) plus 20t squared minus 40t squared is to combine, and we get 200 minus 20t squared over 10 plus t squared, quantity squared. What is this? P prime or dp dt. So what is dp? The same thing, times dt. Let's plug in t equals 2, dt equals 0.4. When we do that, 200 minus 20 times 2 squared over 10 plus 2 squared, quantity squared, times 0.4. This is 4 times 20 is 80. So this is 80, and 200 minus that is 120. This is 4, and 14 squared is 196. 120 times 0.4 is just 48 divided by 196 is 0.245 millions of bacteria, which means 245,000. So what does it mean? The population of the bacterial colony is increasing. Why is it increasing? This is positive. By how much? 245,000. Can we find the exact change? Yes, delta P, the change in population. How do you find the change in population? Well, plug in 2.4, you find the population at t equals 2.4. Plug in 2, you find the population at t equals 2. Their difference is the answer. So if you plug it in, You end up with 0.189, which means 189,000. So one might say 189,000 versus 245,000. That's a huge difference. Yes, here's the reason. If you look at dt or delta t is 0.4 compared to t of 2 is fairly large. If this is small compared to the choice of t, the approximation, it's much better. Use differentials to approximate 51 squared. In algebra, they probably have gone over this, that because a plus b squared is a squared plus 2ab plus b squared, we can put 50 plus 1. So we get 2,500 here. 2 times 50 times 1 is 100. 1 squared is 1. And you should easily calculate 26/1 in no time. So what is the process? Number one, we need a function. What function? Just read the operation 51 squared. What are we doing? What is the operation? Squaring. So the function must be x squared. Second step, choose a number x close to 51 for which squaring is easy to compute. You can do it in your head. Obviously, the answer is 50 because 50 squared is the closest number you can think of, and the answer is 2,500 because 5 squared is 25, and because it's being squared, you put, there is 1 0, you put 2 zeros. If it's cubed, you put 3 zeros, and so on. So it's very easy to calculate. So we are going to use this to get to 51. So what is the difference? The difference is positive 1. So delta x or dx is 51 minus 50 equals 1. Which means we may not know what's 51 squared, but because this is positive, it has to be larger than 2,500. On the other hand, if the question was asking for, let's say, 48 squared, then I hope you see that dx or delta x is negative 2, because 48 minus 50 is negative 2. Again, what does it mean? We may not know what's 48 squared, but it has to be less than 2,500. So we are going to use the approximation f of x plus delta x equals f of x plus dy. We do have f of x, we don't have dy. To find dy, we are going to differentiate and get 2x. And dy is 2x dx. So now we have everything. We have f of x, which is x squared, and dy, which is 2x dx. This is where we got it. I'm going to erase my work so we have enough room to finish the job. What are we looking for? 51 squared, f of 51, f of 50 plus 1, meaning x is 50, dx or delta x is 1. So we're going to go here and say 50 squared plus 2 times x, which is 50, times dx, which is 1. And of course, 100 and 2,500 adds up to 2,600. And as I mentioned, compare it to what we have as an exact answer, 2,601. Needless to say, you notice they are extremely close. And here's the reason. Delta x compared to x is extremely small, so the approximation is great. Very close. And we're done with that. Also, we can use linearization, and everybody remembers linearization means find the tangent line. What is the meaning of that? If you look at the curve, and at some point, for example, at point A, comma, f of A, draw a tangent line. If you are close to this point, and you evaluate the function f of x. First of all, at x, the function and the linearization, meaning the tangent line, result in exactly the same answer. But if you go a little bit to the right or left, not too much, whether you use f of x or L of x makes not much of a difference. They won't be identical, but they will be close. And so it is easier to use a linear approximation. That's the idea. So if you want to do that, you need to know the function. What is the function? Obviously, the function is x squared. What about the point? At what point x equals 50? So we need a pair. How do we find the pair? Plug in. If you plug in, 50 squared becomes 2500. So you want L of x when the pair is 50 comma 2500. And what about the slope? Remember, when you have f prime of x, if you plug in this case 2 times x equals 100, becomes the slope. So having said that, I'm going to go with the easy way out. The point slope y minus y1 means y minus 2500 equals m100. X minus x of 1, that means x minus 50. This is 100x. Oops, let's just quickly write. So this becomes 100x minus 5, and we have 3 zeros. This one, we move it, we make it plus 2500. And y, or L of x, becomes 100x minus 2500. Now, if you plug in 51, in other words, 51 squared equals L of 51, it's 100 times 51 minus 2500, and it's exactly equal to what we got here. If these two are not identical, somewhere we've made a mistake. Use differentials to approximate square root of 27. Well, the same concept. First, we need a function. What function? Just read square root of 27. What is the operation? Square root. So it's square root of x. Number two, we need a number. Choose a number x close to 27 for which the square root is easy to compute. We all should know square root of 25 is 5. So the choice would be 25 because square root of 25 is 5, and that is the closest one. By the way, everybody should know the answer should be between 5 and 6 because 5 squared is 25, 6 squared is 36, but that is the process. So having said that, from 25 to 27, we go up by 2, that is delta x or dx. In other words, 27 minus 25 equals 2. Again, just for the sake of argument, if the question was asking for square root of 24, in this case, dx or delta x is negative 1 because from 25 to 27 plus 2, from 25 to 24 minus 1. In other words, 24 minus 25 is negative 1, which means we may not know what's square root of 24, but for sure is less than 5. We may not know what's square root of 27, but for sure this is positive, it's larger than 5. That's the idea. And so we're going to use the approximation again. F of x plus delta x is f of x plus dy. So what is f of x? We have it. What is dy? We have to find it. To find dy, we are going to find f prime of x dy dx, and then dy. So we are going to change this to x to the power of 1/2. And f prime becomes 1/2. X to the power of 1/2 minus 1 is negative 1/2, or 1/2 squared of x. So that's f prime of x. What is dy? Same thing, times dx. Let's plug in. So we found f of x plus delta x to be equal to square root of x plus 1 over 2 square root of x dx. We want square root of 27. That means we want f of 27. That means x is 25. Dx or delta x is 2. Okay, so if we plug in 25, we get 5 here. So this is 5. This is also 5 times 2 is 10. So 1 over 2 times square root of 5 times 2. This one, as I mentioned, is 5. Let me see what I want to use. I'm going to use this one. So this is 5. This is also 5. These two cancels out. These two 5 plus 1/5 or 5 and 1/5 or 5.2, everybody. Pretty straightforward. Now, for comparison, if we put this into a calculator and write it with many, many, many decimals, square root of 27 is 5.196152423. So with the first decimal, they are identical because it becomes 5.2. With the second one becomes 5.20, identical. So that's really close. Okay. Now, as I mentioned, when you have a function at the point of tangency, you put that x into the original function, or the tangent line gives you the same answer. But if it's close, then it's easier to evaluate it with a line than the curve, and it's a good approximation. So we are going to go with the linearization. And again, I'm going to use y minus y1 equals m times x minus x sub 1. But let's see what we need to do. Number one, what is the pair? If you want to find L of x, you have to know the function. The function is square root of x. At what point x equals 25? So tangent line L of x is of interest to us when the function f of x is square root of x and x equals 25. Which means if I put the 25 here, I get my pair 25 comma 5. And if I put it into the, let me erase the board here. If I put it into f prime, so 25 here is 5, 5 times 2 is 10, 1 over 10, that's the slope. Y minus y1, y minus 5 equals m1 over 10, x minus x of 1, x minus 25. So when we distribute over here, we get 1 over 10 times x minus 25 over 10. This goes to the other side, becomes plus 5 or 50 over 10. 50 over 10 and negative 25 over 10 is positive 25 over 10 or 5 halves. So y or L of x is 1/10 of an x plus 5 halves. What do we want? Square root of 27 or L of 27. What do we do? 1 over 10 times 27 plus 5 halves. And I hope you see that this is 27 over 10, 5 halves, 25 over 10 is 52 over 10. 5 and 2/10, or 5 and 1/5, or 5.2. It's very straightforward. I hope everybody is following that. I just wanted you to see the details. Okay. Measurement error. In a manufacturing process, ball bearings must be made with a radius of 0.6 millimeters, with a maximum error of plus minus 0.015 millimeters. Use differentials to estimate the maximum error in the volume of the ball bearing. So these are ball bearings. As you can see, they are in spherical shape. So we should recognize the sphere. And the sphere has the volume of 4/3 pi r cubed. We should know the formula. And the radius is supposed to be 0.6 millimeters. However, when you manufacture, maybe you don't get the exact radius you want. If it's larger by 0.015, that means it's 0.615, it still works. It will work. It will not get stuck. If it goes beyond that, it gets stuck. Okay, it can't go around. On the other hand, if it's smaller by 0.015, that means it's 0.585, it still works. If it's more than that, it may fall off. I hope everybody understands. So that's the concept. So in other words, it gets smaller a little bit, that's fine. It gets larger a little bit, that's fine. But how much? By this much and no more. So R is 0.6. This represents delta R, or dr, equals plus minus 0.015 millimeters. The volume, as I said, follows the formula for a spherical shape 4/3 pi r cubed. And we want what? Estimate the maximum error in the volume, dV. So that is explanation of the question in mathematical symbol. So a question like this, you should be able to have a rough drawing of a sphere, know the formula for it, and then move on with that. So the volume is 4/3 pi r cubed, and we are looking for dV. F prime of x is dy dx, and dy is f prime of x dx. Now we're going to go with v prime of r is dv dr. And of course, this is just a number, a multiplier, a coefficient remains. We're going to work on r cubed, which gives us 3r squared. And we end up with 4 pi r squared. This is v prime of r, or dv dr. And what is dv? 4 pi r squared times dr. So we are in business. We're just going to plug in. We are going to go back to what we wrote. That's why you write that. It makes it nice and easy here. So you are going to replace the r with 0.6, dr with plus minus 0.015. So the answer is 4 pi 0.6 quantity squared times plus minus 0.015, which is equal to plus minus 0.0216 pi. Again, we keep it as pi as an exact answer, everybody. Now, you always write the exact answer in your notes. If you have to answer with an approximation that they will ask you, then you go with however many decimals they ask. So it's an approximation of plus minus 0.0678584 cubic millimeters. Now, we're done with this. The question is, can we calculate the exact value? The answer is yes. The exact value means delta V, means delta y is f of x plus delta x minus f of x. In this case, would be the volume, okay, of x, in this case, R, the volume of R, plus this number, minus the volume with this number, and of course, minus that. So on the plus side, remember, the volume of 4/3 pi r cubed, we can plug in 0.6 and calculate. Also, we're going to add this and say the radius would be 0.615. Calculate the volume. That means 4/3 pi times 0.615 cubed minus 4/3 pi or 0.6 cubed, and the difference is on the plus side. I have factored out the 4/3 pi. On the other hand, if it's smaller by this much, that means the radius instead of 0.6 is 0.585. So 4/3 pi times 0.585 cubed, and then with 0.6, we've already done that, so we should have the number. So 4/3 pi, I factored it. 0.585 quantity cube minus 0.6 cube gives you that. That means the exact change, we can go up by this much or go down by this much, 0.0221 pi or negative 0.0211 pi. And as you can see, both of them are fairly close to the approximation we have using the differentials.